Hi everyone, my name is Stephen Bates. I'm the Chief Technology Officer at Eideticom, and I'm going to talk to you today about NVMe Computational Storage, a new hope for accelerators and DPUs. In this keynote, I want to talk about how NVMe Express, or NVMe, can be used to address some of the biggest challenges customers face when adopting accelerators, computational storage devices, and data processing units. All these different accelerator devices can offer great performance in terms of increasing the performance of an application and increasing the efficiency of a computer system. However, deploying, managing, composing, and using these acceleration devices at scale and using a common open framework isn't something we have been able to achieve or even aspire to until now. I will talk about how NVMe-based accelerators can take us to the next phase of adoption by providing a vendor-neutral standard and open-source software ecosystem for these devices. Join me for about the next 25 minutes as I walk you through this vision and discuss how my company, Eideticom, is leading the efforts to reach into this brave new world. NVMe is more than just a storage protocol. It's a highly efficient transport for getting messages and data between a host and a device like an accelerator. It's already been hugely successful. It is deployed on tens of millions of devices, and recent analysis reports indicate that the NVMe market is going to grow at 43% CAGR between now and 2025. And in 2025, NVMe will be a $115 market. NVMe is a great protocol for the data center in that it understands concepts like performance, scale, manageability, security, and composability. It follows an open vendor-neutral ethos and is coupled with a free software ecosystem that includes things like operating system drivers, user space frameworks and tools, and open source management tools. As Michael Cornwell, who was then at Microsoft Azure, noted in 2018, NVMe can be leveraged to do much more than just storage, and Eideticom has been a leader in taking NVMe to accelerators since our inception as a company. The future of storage is offload. My friend Sean Lundy coined this phrase, and we really like it. The data center is seeing an evolution as data requirements explode and applications scale out across thousands, if not tens of thousands of servers. The standard approach of using application code on Intel or AMD central processing units or CPUs simply cannot keep up. Moore's law and Dennard scaling are fighting us there, and we need a different approach. So we're moving to a world where compute needs a variety of different accelerators at different times and in different places to get the job done. At the same time, there's a drive towards composable servers that can be constructed and torn down again in a matter of seconds. And that's moving us to more of a rack scale architecture, where instead of having identical servers, we have very simple compute nodes and pools of storage, pools of compute, and pools of accelerators that can be mixed and matched as needed. This makes much more sense, especially when it's combined with a unified framework for these pools of accelerators and storage. And to even allow for devices, storage devices and accelerator devices to exist in the same pools to enable a reduction in data movement. Leveraging NVMe as this unified framework is Eideticom's vision and is similar to the vision of many other builders of and consumers of accelerators, computational storage devices, and DPUs. This vision takes us to a world where the compute nodes become very, very simple and become very homogeneous. And then storage and accelerators can be attached as needed via a fabric. Then NVMe software can be used to compose, manage, and offload key parts of an application to those accelerators, which are close to, are part of the storage. So I'd like us now to dare to imagine the world in which all of this has come true, has existed, has come into existence. Let's dare to imagine a world where NVMe is an open standard and a framework, not just for storage, but also for compute offload. Come with me now and let's step into this world and see what the data center looks like. Imagine moving compute and acceleration closer to your storage to achieve unparalleled improvements in efficiency, cost, and performance. By putting computation near storage, we avoid needing to move data from our storage layer and our pools of storage back to the compute nodes. In fact, we can now simplify our compute nodes because we can borrow these accelerators as we need them and request the right one for the job at hand. When the application is done with it, an accelerator can be returned to the pool to be used by someone else. Stranded resources become a thing of the past. Imagine buying an accelerator hardware from a different vendor and not having to change the software on your server. Today, this is impossible because every accelerator hardware vendor develops a different programming interface and a different driver model. End customers are struggling to evaluate and deploy new solutions because they require a new mix of software that is often closed source and vendor specific. Let's imagine instead being confident that your operating system distribution will work with this new hardware just as it is. This is what already happens for NVMe storage devices today, and the same thing can be true for accelerators. Imagine upstream drivers for your accelerator hardware that are developed and maintained by the best operating system developers on the planet. A vendor-specific programming model for an accelerator means a vendor-specific driver, which means an internally developed body of code that truthfully will be less tested and more buggy than any driver developed in an open manner by teams from multiple companies and end users. These open source drivers will then be merged into upstream operating systems like Linux, VMware, and Windows, and backported by companies like Red Hat and Ubuntu into their distributions. Imagine user space libraries that are free, and when I say free, I mean free as in freedom and free as in beer, up on GitHub, and packaged by your favorite OS vendor by default. Again, there's no need to rely on vendor-specific solutions and non-open source code. Imagine using the same software to talk to direct attach accelerators and accelerators connected via a fabric. This is something that I find incredibly exciting. With the development of NVMe over fabrics and with the development of NVMe Computational Storage, computers can now talk to remote NVMe the same way they do to local NVMe. Companies that deploy NVMe at massive scale are using this feature today to offer performant block and file storage to their customers. Companies like Amazon Web Services and their Annapurna team have developed their Nitro-based systems around NVMe to huge success, and they continue to innovate in NVMe. And the ability to use the same software to talk to a PCIe-based accelerator or to an accelerator at the end of a TCP/IP connection is very powerful, and only NVMe offers this capability today. Imagine using the same open source software to manage your accelerators, and that software is already being used to manage literally millions of existing data center devices. We don't have to worry about NVMe not performing at scale because it already does. Tools like NVMe CLI are used by thousands of operators to manage literally millions of NVMe solid-state drives. And this software has seen the sort of testing that is needed to deploy at this sort of scale in production. The NVMe management specification is a rich and robust standard that can be applied to accelerators just as it is to storage devices. This new imagined world looks pretty wonderful to me, so I'm hoping we can go there together. So if we take what we have imagined as our brave new world, we can look at life before NVMe or BM, which is on the left of this slide. And then we can look to life after NVMe or AM. Today we have a world of great hardware accelerators, but these are vendor specific and therefore red in this diagram. And therefore the software to manage, compose, and drive this hardware is also vendor specific, i.e. red. Customers are unhappy, they're sad, because this makes it challenging to multi-source an accelerator from different vendors, and it means either different or both stacks need to reside on the same compute node. Managing this software challenge is an additional burden the customer really doesn't want to take on, and means adopting new and more capable accelerators becomes problematic. In our vision of the future, we now have NVMe-based accelerators from many vendors that all talk the same language. The same open software stack in green can be used for all these different accelerators and vendors, and a free and open source set of drivers, libraries, and tools can be used. The customer is very happy now because they can source accelerators from different vendors and use the same software in all cases. And this software is open and developed by bodies like the NVMe Express organization and SNIA with a multi-vendor approach to that development. I want to talk next about what I call the 3 C's of the data center, or the 3 C's of accelerators. And those 3 C's are compatibility, consumability, and composability. And I think everything I've discussed so far in our vision can be condensed into those 3 C's. Compatibility is obtained by using NVMe to bring a common programming interface to all kinds of accelerators. Computational storage devices, data processing units, and even classical accelerators like offload engines and GPUs can all align to this vendor-neutral framework. This leads to a single software stack for all, making the end customer's life a much simpler and happier one. It also makes the vendors' lives easier because it's easier to get customers to adopt new accelerators. This is a win-win for customers and vendors. Consumability is obtained by vendors and customer software teams collaborating to develop free and open source drivers, libraries, and management tools. Much of this work is already being done because it overlaps with what we've done for NVMe storage devices. Ultimately, operating systems will include this well-designed and well-maintained software by default, meaning it's going to become as simple as plugging in an NVMe-based accelerator and seeing improvements in an application performance and system efficiency. You literally will go to a website or to a vendor, buy some of their products, plug it into your Linux or Windows or VMware-based server, and things will automatically just work and get better. This is the vision, and this is what we're aiming for. Composability is obtained because NVMe is a transport, and it's already standardized across direct attached protocols like PCIe and remote attached protocols like Ethernet, RDMA, and TCP/IP. As such, accelerators can be deployed either inside the server or at the far end of a network connection, and they will be consumed using exactly the same software model. So now I'd like to talk a little more about the specifics of what my company, Eideticom, is doing to help build this brave new world and create this new hope for accelerators and data processing units. Eideticom is an innovator in this space of NVMe computational storage and has been innovating in NVMe for accelerators, computational storage, and DPUs since our inception in 2016. We're the first company to demonstrate NVMe accelerators over a network using NVMe over fabrics, and we did that at Supercompute in 2017. We've launched storage-centric computational storage devices, NVMe-based computational storage devices, with our partner Bitware. We're a founding member of SNIA's technical working group on computational storage. We've developed NoLoad, which I'll talk about in the next slide, which is the world's first NVMe-compliant computational storage processor that was certified by UNH, who performed the standard certification for NVMe devices. We have an industry first in the first computational storage deployment at Los Alamos National Labs. We're a co-editor of the NVMe Computational Storage Working Group that is working to drive this NVMe for accelerators forward as a standard. We developed NoLoad file system, which is the first stacked file system that uses NVMe-based computational storage to provide offload of storage-centric services like compression. And we've developed the NoLoad Smart SSD, which is an implementation of our NoLoad on the Samsung plus Xilinx Smart SSD product, which combines an NVMe SSD with an FPGA in a storage-centric format. I mentioned NoLoad on the previous slide. So NoLoad is our product based around NVMe computational storage. In this product, we have developed a platform for deploying computational storage services or functions like compression and encryption and data analysis and artificial intelligence inference behind an NVMe interface. So no matter what physical hardware we use, we always present the same programming interface to the host. The customer gets a totally consistent, totally common software programming interface. We can deploy on many different types of hardware. 3 examples on this slide are the Alveo U50 card from Xilinx, what we call the NoLoad U50. I mentioned already we deploy on the Xilinx Samsung Smart SSD in our NoLoad Smart SSD, and we deploy on our partner Bitware's U2 form factor product in the NoLoad U2. Those are the specific hardware components, but in terms of what services we provide, how we make the customers happy, we perform tasks for them rather than them performing them on the central processing unit. And some of those tasks that we've taken into product include transparent compression, database acceleration, and data analytics. And in all cases, we align with the NVMe standard in order to do that particular piece of work. I want to talk a little now about our stacked file system, NoLoad file system. This is the first NVMe computational storage file system. And this particular file system provides a range of different services. In this case, I'm going to focus on compression. So we've had compression as a service on our products for a while. And we had some customers who said, I really like what you guys are doing, and we love that you offer it through the NVMe programming interface. But we don't necessarily want to change our application in any way to leverage your compression services. Our user space code is not to be changed. For those particular customers, we wanted to work with them on their existing file systems, which perhaps were ext4 or XFS, and provide them a mechanism for obtaining the compression without changing the user space application and without changing the underlying file system. We did that using NoLoad file system, a stacked file system that takes advantage of any of the NoLoad devices in the system, regardless of what form factor they're in or where they're located, and combine that with the power of NVMe storage to provide a transparent compression solution. So the applications running in user space, for example, something like Hadoop, like on the left side of this slide, or something like a database on the right-hand side of this slide, can continue to perform without any code changes and yet see a material benefit in terms of deployment cost and performance by leveraging our products in the form of the NoLoad accelerators and the NoLoad file system. We've had customer successes with this for databases and for large data analytics systems. And the initial version of our product targeted compression, but we are now looking to expand that into analytic-based offloads as well. So this provides you acceleration without application changes. Another customer success story I'd like to talk to you about is with Los Alamos National Labs. We've worked with Los Alamos for a number of years, and they are great believers in NVMe Computational Storage. And they worked with us on our vision to deploy computational storage at scale in their high-performance computing systems. We worked with them to offload storage functions into our accelerators, which were again presented as NVMe computational storage devices. And by doing so, we enabled line rate compression, which improved CPU utilization and reduced memory bandwidth pressure. What this resulted in was a reduced TCO and capital costs, so an overall reduction in costs for the solution. We enabled higher performance, and we did all of that for lower power. We published a white paper on this with Los Alamos, and if you're interested, you can access that from our website. So I want to finish off with a slight variation on one of the quotes that I gave you earlier. The future of storage is offload. There is no doubt of that. Computation is scaling dramatically, storage is scaling dramatically, and the amount of data that we would have to move in order to process it, if we were to do things the way we're currently doing them, is not sustainable. So acceleration has to move to storage. And NoLoad is a innovative product and a real kind of world first in the space of NVMe-based computational storage. And Eideticom is driving product into this market. We're driving solutions into the market, and we're setting technology leadership with our roles on the NVMe standardization and our roles within SNIA. So I'd like you to come with me into the brave new world of NVMe-based computational storage and help me create a new hope for the deployment of accelerators and data processing units and all other kinds of accelerators. My name is Stephen Bates. I'm the Chief Technology Officer at Eideticom, and I want to thank you very much for your time.